considered the x component of electric field, and we considered that x component of electric field is a function of z and t. So in space it is only a function of z. Then we found out from that that the magnetic field has only y component. It is also a function of z and t. Then we eliminated from the two Maxwell's equation component form of two Maxwell's equations. Then we eliminated the B magnetic field, and we found out an expression and one equation for electric field Ex. Then we made a substitution for the variables. We made a substitution for variables. U plus is equal to Z plus Ct, U minus is equal to Z minus Ct. Then we saw that time derivative of U plus with respect to t is equal to C, derivative of U minus with respect to C with respect to t is equal to minus C, derivative of U plus and U minus with respect to Z is equal to 1. This is what we saw up to now. So now let us proceed with solution of this equation. Dou square Ex is equal to 1 by c square dou square Ex by dou t square. Now if you look at this, on the left hand side we have an operator dou square by dou z square which is operating on Ex. On the right hand side we have an operator 1 by c square dou square by dou t square which is operating on Ex. Now let us take the right hand side to the left hand side and put the operators together. So we can have a new operator which is dou square by dou z square minus 1 by c square dou square by dou t square. This operator is operating on Ex. Ex is a function of z and t, and by substitution we have converted Ex to be a function of u plus and u minus. So this operator dou square by dou z square minus 1 by c square dou square by and dou t square is now operating on Ex, which is a function of u plus and u minus. Now from this point onward, when I say Ex, I will mean that it is a function of u plus and u minus. Inherently or implicitly, Ex is a function of z and t, but we will not consider z and t for the time being. Now consider one. 1 by c dou by dou t operating on Ex. Let us consider what that will give us. 1 by c dou by dou t operating on Ex, that you can write as 1 by c dou by dou t. Use the chain rule there. Dou by dou t, for dou by dou t we can use dou by dou u plus by dou t. So this will become 1 by c dou Ex by dou u plus into dou u plus by dou t plus 1 by c dou Ex by dou u minus by dou t. Why we have got this plus term? Because Ex is a function of u plus and u minus both, and we are considering partial derivative. Therefore, this we can dou by dou t we can write as this 1 by c dou Ex by dou u plus by dou t. So this is for u plus term, plus 1 by c dou Ex by dou u minus by dou t. This is for u minus term. Now you know dou u plus by dou t is equal to 1, dou u minus by dou t is equal to 1. Therefore, this will be equal to dou Ex by dou u plus minus dou Ex by dou u minus. Because dou u plus by dou t is equal to c, dou u minus by dou t is equal to minus c. So putting c for dou u plus by dou t, that cancels out the c in the numerator. Similarly, putting minus c for dou u minus by dou t, c cancels out in the numerator and plus becomes minus. So accordingly it becomes dou Ex by dou u plus minus dou Ex by dou u minus. Now from this you can say that 1 by c dou by dou t, this operator 1 by c dou by dou t is equal to dou by dou u plus minus dou by dou u minus. this operator is equivalent to or is equal to dou by dou u plus minus dou by dou u minus. So this is about on the operator 1 by c dou by dou t. Now let us consider the operator dou by dou z. Dou by dou z operating on Ex will follow the similar principle. It will be dou by dou z, and dou by the dou u plus, then dou u plus by dou z, plus dou by dou u minus dou u minus by dou z. Dou by dou u plus by dou z, so dou u plus by dou z is equal to 1, dou u minus by dou z is equal to 1. Therefore, this will be equal to and dou by dou u plus dou by dou u minus. Both are operating on Ex. So since left hand side and right hand side are operating on Ex, we can simply write dou by dou z, the operator dou by dou z is equal to dou by dou u plus, goodly, next, dou by dou u plus dou by dou u minus. So this how we can write this way. So two operators we have got. For 1 by c dou by dou t, this operator can be replaced by dou by dou u plus minus dou by dou u minus. Similarly, the operator dou by dou z can be replaced by dou by dou u plus dou by dou u minus. Now the equation that we have to solve is dou square by dou g square minus 1 by c square dou square by dou t square, that operating on Ex is equal to 0. Now what we will do is write this in this manner. Dou by dou g square is equal to dou by dou z operating on dou Ex by dou g. Similarly, minus 1 by c square dou square e by dou t square, that we can write as 1 by c dou by dou t operating on 1 by c dou Ex by dou t. So that will be equal to 0. Now look at the bracketed term. The bracketed term on the second term, on the left hand side, the second term, there if you consider the bracketed term, we have 1 by c dou by dou t operating on Ex. But 1 by c dou by dou t is equal to dou by dou u plus minus dou by dou u minus. Similarly, on the first term, on the left hand side is dou by dou g operating on Ex. Dou by dou g is equal to dou by dou u plus dou by dou u minus. So let me put that. If we put that, so that will give me dou by dou u plus dou by dou u minus. That how will operate on dou by dou u plus dou by dou u minus. So whole thing will operate on Ex. Then the second term will be minus dou by dou u plus minus dou by dou u minus. From where we get this? This is 1 by c dou by dou t. So that is operating on again dou by dou u plus minus dou by dou u minus Ex. Now if you look at this, this is of the form x plus y into x plus y. Then that is the first term. Second term is x minus y into x minus y. Now x plus y into x plus y is equal to x square plus y square plus 2xy. So x square will be, if I consider that way, will get dou square by dou u plus square, then plus 2 dou square by dou u plus into dou u minus plus dou square by dou u minus square. So these two will be from the first term. So that is Ex. Then minus, this is x minus y into x minus y form. So this will be x square will be dou square by dou u plus square. Then plus y square, which is the last term, this dou square by dou u minus square. So that will be the last term. Then in the middle term we will have minus 2xy. So that will be minus 2 dou square by dou u plus into dou u minus. Now we have to simplify this equation. So when we simplify this equation, look at the first term. First term is dou square by dou u plus square. Then in the second term we also have minus dou square by dou u plus square. So they will cancel out. Similarly, in the first bracketed term we have dou square by dou u minus square. In the second bracketed term we have minus dou square by and dou u minus square. So plus minus that will cancel out. Then in the first bracketed term we have 2 dou square by dou u plus dou u minus. In the second bracketed term we have minus 2 dou square by dou u plus dou u minus, and that is preceded by a minus, so minus minus is plus. So ultimately we will get 4 dou square by dou u plus dou u minus ex is equal to 0. So that gives us, since 4 is non-zero, so that gives us dou square by dou u plus dou u minus operating on ex is equal to 0. Now we have to solve this. This is the equation. Ultimately we reach a stage, a simplified stage, where for ex we got dou square by dou u plus dou u minus e operating on ex is equal to 0. Now we have to solve this. To solve this, let us see an example. Then from that example, we will come back to this. So suppose v is a function of x, and v is any function. So we have dou v by dou x is equal to 0. This is the condition given to us. Dou v by dou x is equal to 0. If this is a condition given to us, this implies that v is a constant. So v is a constant k. So here we can write v is a constant k. Okay. Then let us say we are given another condition. Dou by dou x operating on dou v by dou y is equal to 0. Now dou v by dou y is equal to 0. That indicates that v is a constant k. So the dou v by dou y is not 0 here. Dou v by dou by dou x of dou v by dou y is equal to 0 indicates that dou v by dou y is equal to a constant. So dou v by dou y is equal to a constant. So v is equal to a function of y. So that gives us dou v by dou y is equal to constant, gives us that v is equal to a function of y. So let us say v is equal to fy. Similarly, now x and y are independent upon each other. Therefore, this operation we can interchange. That we can write dou by dou x. If dou by dou x operating on dou v by dou y is equal to 0, then dou by dou y operating on dou v by dou x will be equal to 0, which means again v will be a function of x. So v is a function of x, v is a function of y, and this has to be additive operation. So v is equal to fy plus gx. F is an arbitrary function, g is an arbitrary function. Now let us see whether this is valid or not. So if v is equal to fy plus gx, find out dou v by dou y. Dou v by dou y will be dou f by dou y plus dou g by dou y. Since g is a function of x, dou g by dou y will be equal to 0. So dou v by dou y is equal to dou f by dou y. Now dou by dou x of dou v by dou y will be dou by dou x of dou f by dou y. Now f is a function of y, so dou f by dou y is a function of y only. So dou by dou x of a function of y, since that is a function of y only, dou by dou x operating on a function of y is 0. So this form is the proper form. Now since we know this is the proper form, now if you take f dot g fy into gx, this will not give you the proper solution. If you take v is equal to fy into gx, then dou v by dou y will be gx into dou f by dou y. So put that gx into dou f by dou y, so that will ultimately give dou by dou x of operating dou v by dou y not equal to 0. So b cannot be f into g, v has to be f plus g, where f is a function of y, g is a function of x, or you can interchange that. F is a function of x, g is a function of y, that also you can write. Now here what, and look at our equation. It is dou square by dou u plus and dou u minus into ex, that is equal to 0. That operating on ex is equal to 0. Now compare that with this equation. Dou square v by dou x dou y is equal to 0. So v is equal to ex. If we compare that, v will be equal to ex, u plus is equal to x, y is equal to u minus. So if we put that, then v will be ex. So ex will be a function of u plus. So ex will be f u plus plus g u minus. So the form of ex will be this. Ex is equal to f u plus g u minus. So this is the form of electric field in the x component of electric field that we are considering. So this will be the form of electric field. We'll consider what is f and g later, but ex will be f u plus g u minus, where u plus is equal to c z plus ct, u minus is equal to z minus ct. Therefore ex is equal to f of z plus ct plus g of z minus ct. Now let us find out what is dou ex by dou z. That we know dou ex by dou z is equal to minus dou by by dou t. And this you can see the red equations in red on the top right hand corner. The second equation from Maxwell's equation, we had got this equation, dou ex by dou z is equal to minus dou by by dou t. Similarly, we have got the first equation is minus dou by by dou z is equal to 1 by c square dou ex by dou t. We have found the form of ex. Now we have to find the form of by. So let us start with this. Dou ex by dou t. Dou ex by dou t is equal to dou by dou t of f plus g. So dou ex by dou t is equal to dou by dou t of f plus g, where f is a function of u plus, g is a function of u minus. So that we can write dou by and dou u, dou f by dou u by dou f by dou u plus by dou t, that will be the first term, plus dou g by dou u minus by dou t, because the first term f is a function of u plus only, g is a function of u minus only. So for f we'll use the chain rule in u plus, for g we'll use the chain rule in u minus. That will give us dou f by dou u plus by dou t plus dou g by dou u minus by dou t. Now you know dou u plus minus dou by dou t of u plus minus is equal to plus minus c. So put that how. So if I put that and take c common from both the terms, then dou ex by dou t is equal to c into dou f by dou u plus minus dou g by dou u minus. F is a function of u plus, g is a function of u minus. So we got an expression for dou ex by dou t in terms of f and g. So dou ex by dou t, that we can write as c into dou f by dou u plus minus dou g by dou u minus. U plus and u minus, you know, j plus is equal to z plus ct, u minus is equal to z minus ct, that we know. Now okay, So from this we have got dou Ex by dou t is equal to this. So now let us write dou Ex by dou t. Again let us write it in terms of z. So dou Ex by dou t is equal to C. We'll use the chain rule using z. And so Ex is a function of z and Ex is a function of t. So we'll use the chain rule using z. Dou Ex by dou t is equal to C dou f by dou u plus. So for that we'll write C dou f by dou z into dou z by dou u plus. Dou f by dou u plus, since u plus is a function of z and t, so for since it is a function of z, we can write this way. So dou f by dou z into dou z by dou u plus, minus for z, g also we can write this way, minus dou g by dou z and dou g by dou z minus into dou z by dou u minus. Now you know what is dou z by dou u plus and dou z by dou u minus. These two we know that is equal to 1 because dou u plus by dou z is equal to 1, dou u minus by dou z is equal to 1. That indicates that dou z by dou u plus is equal to 1 and dou z by dou u minus is equal to 1. So if you put that, that gives us the dou Ex by dou t is equal to C dou f by dou z minus dou z by and dou z. Now we have got these two terms. Now let us write this simplify this. Dou Ex by dou t is equal to C dou by dou z of f minus g, and this we have seen. Now 1 by c square dou Ex by dou t will be equal to, if I multiply c square on both the sides, so 1 by c square dou Ex by dou t is equal to 1 by c dou by dou z of f minus g. Now 1 by c dou by dou z of f minus g, that you can see is equal to minus dou by by dou z, because 1 by c square dou Ex by dou t is equal to minus dou by dou z. So 1 by c dou by dou z of f minus g is equal to minus and dou by dou g. So from that we can say that by, and look at the last two terms in this. In the last two terms we have differentiation with respect to z. So if you integrate both the sides, we will find out what is by. Integrate both the sides with respect to z, that will give us by. So by will be, by integrating the left hand side, that will give us 1 by c fu plus minus gu minus plus ht. Ht is a constant with respect to z, but it can be a variable in t. So we get what is by. By is equal to 1 by c f u plus minus gu minus plus ht. Now by using proper condition, using the expression for Ex and By, now we use the expression for Ex and By in dou Ex by dou z, which is equal to minus dou by dou t. So if you use the expression for Ex that we have got and use the expression for By that we have got now, use them in this equation, then that will show us that Ht is equal to 0. This is very simple, so I am not going to consider that or uh, and talk about that. So that will give us this. So once ht becomes 0, then we find out that Ex is equal to f plus g and by is equal to 1 by c f minus g. Now f and g can be any arbitrary function. So f and g can be same function, g can be equal to f, or they can be different functions, but they can be any arbitrary functions. So Ex will be of this form, Ey will be of this form. This will be the general form of Ex and general form of Ey, which means Ex is equal to F of Z plus Ct plus G of Z minus Ct. Similarly, By will be 1 by C into F of Z plus Ct minus G of Z minus Ct. Now what will be F and G? You take any function for F, any mathematical function for F that will satisfy this equation. So if you take Ex in this form with any mathematical function for F and any mathematical function for G, that will satisfy the Maxwell's equation. Similarly, By is equal to, in this form, take any mathematical function for X, any mathematical function for G, that will satisfy the Maxwell's equation. If you take any mathematical function for X, like F can be sine function, F can be cosine, F can be exponential, F can be tan hyperbolic, F can be anything, sine plus cos. So F can be anything, any function. F can be x square, so anything. And so if you take it in any function, any mathematical function, that is going to satisfy the Maxwell's equation. If Ex is in this form and By is in this form, where U plus is equal to Z plus Ct, U minus is equal to Z minus Ct. There is another thing that I will like you to do as homework, that I said U plus is equal to Z plus Ct and U minus is equal to Z minus Ct. You can write U plus is equal to Kz plus omega t, U minus is equal to Kz minus omega t. So, and prove that that also satisfy in this form. U plus is equal to Kz plus omega t, U minus is equal to Kz minus omega t. If you take that, where K is equal to 2 pi by lambda and omega is equal to 2 pi f, or omega, you can say omega is equal to 2 pi c by lambda. 2 pi f is 2 pi c by lambda, so that you can write k is equal to 2 pi by lambda and omega is equal to 2 pi f. So take that and write U plus is equal to Kz plus omega t, U minus is equal to Kz minus omega t, and solve that and find out that Ex will be of this form, By will also be of this form. Now compare these two equations, the equation for Ex and By, and try to remember what we discussed about transmission lines. In the transmission lines, we considered the voltage, expression for voltage and expression for current. The expression for voltage at any point on transmission line is equal to V plus plus B minus, where V plus is forward propagating, B minus is backward propagating. Similarly, the current is equal to 1 by Z into V plus minus B minus. Compare these two, these are same, equal in the of the same form. So F U plus can be V plus, B minus, G U minus can be V plus. Similarly, 1 by C is equivalent to Z, and so that way this gives you Ex is equivalent to voltage, By is equivalent to current in the transmission line. This is in the field. In terms of field, electric field, and in terms of transmission line, it is voltage. In terms of field, magnetic field, in terms of transmission line, it is current. Now what does this U plus and U minus signify here? U minus is equal to Z minus Ct, which means it is a forward propagating wave. Forward propagating wave means the wave is propagating outward from the source. So it is not coming towards the source, it is going away from the source. That is what is called a forward propagating wave. U plus is equal to Z plus Ct So that gives you a backward propagating wave, which is a wave which is coming towards the source or sink. So since it is coming towards the source, so it will come to the source. So that we call the sink. So it is coming towards the sink. So and the wave which is coming towards the source, that is called backward propagating wave. The wave that is going away from the source, that is called the forward propagating wave. So we have both Ex contains a forward propagating wave and a backward propagating wave. So with this we come to conclusion of today's lecture, and next part we will consider in the next class. Now we'll consider the potential what we discussed in the last class, that I will try to revisit in the next class. I assume that last class was little bit difficult, but I hope this class is okay with you.